Another example, assume that future adolescent suicide in the studied population will follow a Poisson distribution. What's the probability that a randomly selected future month will be one in which either, look at this question, either 3 or 4 suicides will occur. So we have two values, either 3 or 4. Return back to the equations. How can we deal with or? And we have another statement called and. So we have multiplication rule or addition rule. So if you want to solve this question, since the two events are mutually exclusive, now we do need to determine they are mutually exclusive, of course. Okay? We use the additional rule to obtain them. Why do we use the additional rule here? Because we have in the question here is or, not and. Return back to the previous lecture and you will find it. So, by applying this question or applying the equations, you can find the probability of being x equal to 3 plus the probability of being x equal to 4 will yield those things. The probability of x equal to 3, we calculated from the previous example that yielded 0.221584, and just only apply all the equations, lambda and the e, you can find it, and the factorial will be 3. It's a 3. So return back to the previous slide, you will find it. The result will be 0.221 plus what we call the probability of being x equal to 4 will be e to the power of minus 2.75 times 2.74 to the power of 4. Why 4? Because we have 3 or 4 suicides. Okay? So 4 over factorial 4 actually, not 3. You do need to correct it. 4 factorial, not 3 here in the denominator. Okay, I will check it. So you do need the final question or final result will be 0.3738922. This is the probability to obtain what? Okay, if we randomly select a future month, will be one which is 3 or 4 suicides will occur. So if we select randomly monthly from this period, we have a period, we have an interval, okay? The probability of being just only 3 or 4 suicides in this month will be 0.373922. This is the final answer. And as we discussed in the previous lecture with the binomial distribution, we have also here ready-to-use tables, actually, just like those used in the binomial distribution, but they are different tables, not as those tables used in the binomial distribution. So we have a title here using the tables that gives them cumulative probability for various values of lambda and x, and you can see here in a study of a certain aquatic organism, a large number of samples were taken from a pond, and the number of organisms per sample was found to be 2. Assuming that the number of organisms followed the Poisson distribution, and again we indicate here it's a Poisson distribution, find the probability that the next sample taken will contain 1 or fewer organisms. So the final question here, the sample will be taken contain 1 or fewer organisms from this pond. Okay, this is a pond, this is aquatic organism, it has so many. They are dealing with the aquatic. Okay, what's the probability of being contain 1 or more or fewer organisms? Here we are dealing with the cumulative frequency, and the cumulative frequency rules that have been discussed early in the classroom, and also I repeated in my previous videos or lectures. So in the table we will see that when lambda equal to 2, the probability that x is less than or equal to 1 is 0.406. That's the probability of being x is less than or equal to 1 over 2 is equal to 0.1 or less than, sorry, the question, less than contain 1 or fewer, okay, less than or equal to 1, okay, equal to 0.406. So we have you need to return back to the tables that are lambda and x. It's a Poisson distribution table. In the textbook that I have already uploaded in the e-learning system, you need to return back to that tables, and you can find the lambda equal to 2, and these values can be obtained from those tables. Another example, find the probability that the next sample taken will contain exactly 3 organisms. So the solution will be like this: the probability of being x equal to 3, okay, equal to the probability of being x less than or equal to 3 minus the probability of being x is less than or equal to 2. Those values less than, it's a cumulative frequency. You can return back to the table of the Poisson distribution, lambda and x. You can see x and lambda right there, and the lambda, you can find that the values for the less than x less than or equal to 3 will be equal to 0.857, and x of less than or equal to 2 will be 0.677, and the final answer will be 0.18. It means that it's the probability of obtaining exactly 3 will be 0.18. Why do we subtract 3 from 2? The probabilities of being 3 from 2, because the question contains exactly 3. Exactly 3 again. You do need to concentrate in that. You do need to understand the question before proceeding in its solution. Find the probability that the next sample taken will contain more than 5 organisms. This is another example. Find the probability that the next sample taken will contain more than 5 organisms. I think we do need to use the complementary probabilities. From here, you can see the solution. Since the set of more than 5 organisms does not include 5, we are asking for the probability that 6 or more organisms will be observed from this thing. This obtained by subtracting the probability of observing 5 or fewer from 1, as we trained previously. I give it to you. Actually, we discussed more than 5 or 6 examples related to this complementary probabilities. So we will need to subtract, okay, the probability of being 6 or more from it, and we will get the answer. Return back to the table again for lambda and x, and you can find again the table from where? From the textbook that has been uploaded in your system, in your e-learning site. The probability here of being x is more than 5, okay, equal to 1 minus the probability of being x less than or equal to 5, and this number, which is 0.938, we take it from the table. Again, we take it from the table, and you can calculate it by yourself by using the previous equation that used e and lambda and x's, okay, and the factorial things, okay. So it will yield 1 minus 0.983 will be yield this value, and this is the probability of observing, okay, observing 5, more than 5 organisms in this point.